Take it as.
Dr. Rasmi,
Yes, sir.
who is the anchor for this program?
Harita?
Harita.
Angel
I'm
is
there, ma'am.
Angel.
Angel. Okay. Angel, you start.
Yes, ma'am.
Please start. Yes.
A very good afternoon to respected dignitaries. Dr. R.B. Singh, former Chancellor, CAU Imphal. Dr. A.K. Singh, Director, Vice Chancellor, IRI. Dr. G.P. Singh, Director of Indian Institute of Wheat and Barley Research. Dr. Rashmi Agarwal, Dean and Joint Director, Education. Distinguished eminent scientists, heads and professors of different divisions, senior faculties and students. I welcome you to the last award lecture series of today, the 8th Rao Bahadur B. Vishwanath Award, which is given to commemorate the memory of late Rao Bahadur B. Vishwanath, the first Indian Director of Indian Agricultural Research Institute. I now request our Honorable Director, Dr. A.K. Singh, to kindly give the welcome address and apprise the audience about the award and formally introduce the chairperson, the most distinguished scientist, Dr. R.B. Singh, to the august gathering.
Thank you, Angel, and it's my proud privilege to welcome each one of you to 8th Rao Bahadur P. Vishwanath Award Lecture. And this lecture is going to be chaired by Professor R.B. Singh, past President, National Academy of Agriculture Sciences. And the award is bestowed upon Dr. G.P. Singh, Director, ICR, Indian Institute of Wheat and Barley Research, Karnal. My colleague, Dr. Rashmi Agarwal, all the faculty members, professors, heads of the divisions, the students, and we have a few very distinguished guests with us in Professor R.M. Singh, Professor B.D. Singh, and Dr. K.V. Prabhu. All have been directly associated with the winner of the award and also the chairperson of the award. And what a pleasant moment for the fraternity of Banaras Hindu University that this moment we are witnessing today. I extend a warm welcome to you all to the 59th Convocation Program. We had first 2-day presentation of gold medals by the students, and that was chaired by Dr. B.D. Singh, and it was an excellent conducted session in terms of very lively and encouraging discussion. The students were all very happy. And then we had the presentations by professor on the significant research findings of the other students who could not make to the medal presentation from different disciplines. And that also went well for last 2 days. And the morning we had the other award lectures, Hooker Award and Hari Krishna Shastri Award. And now we are going to have Dr. V. Vishwanath Award lecture presentation by Dr. P.P. Singh. This award lecture, as it was said, was instituted in 2005 in the memory of pioneer agricultural scientist who became the first Indian director of IRI in 1935. On behalf of the entire faculty and other staff members of IRI, I would like to pay my humble tribute to this great scientist of India whose contributions were all recognized during the British rule and thereafter. He is known for organizing the Grow More Quality Food campaign to keep the nation free from hunger and free from diseases. This biennial award has been instituted to recognize the outstanding research in agricultural sciences and to improve, to provide the incentive for excellence in agriculture research. To chair the award lecture, we have Professor R.B. Singh, Padma Bhushan Professor R.B. Singh, and this audience knows him very well. I feel sort of words to tell about him, but I will try to make a brief attempt because we would like to listen to Dr. G.P. Singh more on his scientific attainments. Professor R.B. Singh did his graduation and post-graduation from Government Agriculture College, Kanpur, and then PhD from North Carolina State University. And he joined as economic botanist cotton at Punjab Agriculture University, Louisiana, and then became the youngest dean and professor at 29 years age at CCS University, Meerut. then went on to serve Himachal Pradesh Agriculture University for a very brief period. And after that, 1972, joined the Banaras Hindu University, which was in true sense his karma bhumi for almost 7 years till 1979. We could have only a very brief glimpse of him when I joined as BSc Agriculture student. Dr. Misra, please mute yourself. So that was 1979. He left for FAO to join as Regional Genetic Resources Officer, then Regional Plant Protection and Production Officer, and Senior Scientist in Technology Division. Before he came back to IRI to serve as Director IRI and then Chairman ASRB. And then he went on to become Assistant Director General FAO, which is again a rare distinction for an Indian to have achieved. And after serving there for about 2 years, he came back and joined as the member of Farmers Commission. Today, you see there is so much of discussion happening about farmers, their demand, and the Swaminathan Commission reports. Every television channel that you open, the social media that you open, always there is discussion about Swaminathan report, and Professor R.V. Singh was the, a very critical input provider in coming up to the C2 plus 50% recommendation and many more recommendations which are not generally known to people and public about the well-being of farmers. And then after the Farmers Commission, he became president of the National Academy of Agricultural Sciences, served as the Chancellor of Central Agricultural University at Imphal, and he has been a very active member of the National Academy of Agricultural Sciences all these days. The enormous contribution, the kind of publication that he has brought at the Academy is really monumental. We are really pleased to have you, sir, to chair this award lecture by Dr. G.P. Singh. Dr. G.P. Singh did his master's with Professor R.M. Singh, and he is also here, fortunately. What a pleasure. And then Professor V.D. Singh taught us, Dr. Prabhu, myself, Dr. G.P. Singh, all of them. We had basic genetics course and plant breeding course taught by Dr. V.D. Singh, and Professor R.V. Singh was also teacher to Dr. Prabhu, along with Professor R.M. Singh and Dr. V.D. Singh. So it's a very pleasant moment for me in particular to see this, the entire gathering, and we are now joined by almost 276 participants. I will not take any more time. I would like to request Professor R.V. Singh to kindly introduce the speaker, Dr. J.P. Singh, who is going to deliver the award lecture. Professor R.V. Singh.
Thank you. So, Director IRI, Professor A.K. Singh, Dean Rashmi Agrawal, distinguished recipient of the Rao Bahadur Dr. B. Vishwanath Award, Gyanand Pratap Singh, the distinguished faculty of IRI, particularly the distinguished participants, Vinod, Rishi, BD, and of course, Man Singh ji, and many other distinguished colleagues, friends I notice and see here. Dear students, I'm sure many students must have also joined. This week is the most auspicious week for any student's life in IRI, and for that purpose, for the country as a whole, in the sense that IRI accounts for the kind of leadership for agriculture which is unparalleled in the world, and therefore it is a very auspicious week, convocation week, where the academia, where Saraswati Maa ki puja सर्वश्रेष्ठ है और वही हो रही है. My congratulations to the colleagues who have organized this so beautifully, and I thank them for giving the opportunity for me to be a part of the celebration. I am delighted to introduce the speaker of the day, and that speaker is none other than the wheat man of India. And if we have the wheat man of India, you can imagine what wheat means for India. And if that wheat man is here, obviously this is a very, 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 very important occasion for us. He is none other than, as we have mentioned his name earlier also, Gyanan Pratap Singh, the director of the Indian Institute of Wheat and Barley. Gyanan graduated from Banaras Hindu University, as Ashok mentioned. Many of his teachers are here. As a matter of fact, I think it was in 1984 he graduated, and you'll be so happy that he received the coveted Malviya Gold Medal to be the most distinguished student of his graduating class. And he got his master's degree from the same institute, Banaras Hindu University, in 1988. And in 1992, Chandrasekhar Azad, again, something common with you, Gyanan. I also was a student at Chandrasekhar Azad Agriculture University and a lecturer there also, and so was Rishi and so forth. So I mean to say so many commonalities. And then his first posting as a scientist, as he had joined ESRB in 1993, if I'm correct, at Shimla, at the Central Potato Research Institute. So he did not stay for too long because he had always the smell of wheat somewhere. And he came to Karnal. Then it was the Directorate of Wheat Research in those days in 1996. And from Karnal, after 5 years being there or so, he came as a senior scientist to the Division of Genetics of IARI, and where he really performed the kind of unparalleled achievements that he was able to achieve. He has dedicated 3 decades, almost 3 decades of association with the best of science, particularly wheat, has really been something phenomenal. I say phenomenal because to have either directly, indirectly, or in association develop more than 50 varieties of wheat is something unheard of. And this speaks in volumes about his contributions. And not only that, he has always done this keeping in mind what is needed by the nation. Today, nutritional security is much more important than food security. And 5 of his varieties are biofortified, in other words, supporting the nutritional security in the country. And those contributions in terms of, I will not name all the varieties, but quite a few of them which are so very important, particularly, let us say, DBW187, 222, and then ST2967. Again, he was associated with this, along with which Dr. Prabhu and other colleagues, and that variety, and along with the variety ST3086 and so on. If in any country of this magnitude of wheat production, almost 50% of the wheat production is based on these varieties in the nation. This you will never hear from anywhere in the world. I think the IRI should bring it out very clearly that this is a unique experience, that from one institution, the varieties released by a group of people dedicated to this kind of real development is something unique in the world. And I think that uniqueness is simply because of the dedication of the outstanding scientists of IRI and the team that was able to work together to really bring this happen. I would also say that most importantly, when we talk of the management of crops, the biotic and abiotic stresses are most important besides the per se yield. And Gyanan was able to also introduce the genes for the wheat blast resistance to the threat, which was threatening wheat. He was able to keep it away. So this is called imaginative thinking, planning of research to think of what is coming up. I wish we could have seen COVID-19 is coming and we could have done something before that it came and struck us. So that is the kind of imaginative thinking. Likewise, his varieties also possess heat and drought tolerance. And today, the climate smart agriculture is the need of the day. And in that process, to give the kind of coverage to these stress factors, biotic and abiotic stresses, by genetic alchemy of crops like wheat, which provides the magnitude of opportunities to do best of genetical enhancement, that was really made best use of it. As you all know, he has contributed in many other ways, published more than 200 papers and many other books and bulletins and so on and so forth. He has received 50 national and international awards. If I keep listing them, I will be probably eating in your time that you are waiting to listen to him. And as you all know, I was so delighted to see that when he became the National Fellow of the National Academy of Agricultural Sciences, many more things are waiting for him, I'm sure. The wheat mine of India, like the milk mine of India. You know, I had the privilege of giving the Korean Memorial Lecture also at Michigan State University. They had invited us the first memorial lecture. And he is the milk mine of India. And here is the wheat mine of India. So milk and wheat, if these two are together, your food and nutritional security is ensured with fortified wheat. And this is something really unique that I see it together. So I will not stand between you and the distinguished speaker. I will request Dr. Gyan Pratap Singh to kindly deliver his speech, please.
Thank you very much, sir. I very modestly accept your appreciation. I do not know whether I deserve it or not. Most respected Professor R.B. Singh Sahab, I would address him as former chairman of the QRT of Indian Institute of Wheat and Barley Research. Many of my teachers, Professor R.M. Singh Sahab, Professor B.D. Singh, Dr. K.V. Prabhu Sahab, whom I have enjoyed working for more than 14, 15 years. It's always a pleasure to see him when he is in the audience. I also feeling nervous because of so many great personalities watching me. But do hope that will deliver the good. I guess I would have some 40 minutes time to do the presentations. If the chairman permits, I will go for the screen sharing.
Go ahead, please. Ashok is there to advise us.
No issue, sir. That's fine.
So at the outset, the distinguished audience, I would like to thank the Director, Dr. A.K. Singh Sahab of Indian Agricultural Research Institute. And as very rightly pointed out by Dr. Prabhu Sahab, that I am the probably only one man who has received most coveted 3 best awards of IRI. And I thank you from my core of heart for this. Sir, initially I thought of presenting wheat improvement for abiotic stress tolerance, but I have included stress as a whole and also how we can increase the profitability of the wheat farmers by doing crop improvement. So in the beginning, I would also like to pay tribute to Rao Bahadur, Dr. B. Vishwanath, a legendary man with commendable work on a wide range of subjects, including soil science, fertilizers, plant and animal nutrition, sugarcane research, economic utilization of agricultural products and waste, a visionary researcher who prepared the first soil map of India, and also first Indian director of Indian Agricultural Research Institute. Sir, to begin with the talk, I would like to discuss something about the challenges we face in terms of population and also the food requirement, as India faces a major challenge to attain its food production target, which is approximately estimated to around 355 million ton by 2030, an ever-growing population which is likely to reach 1.5 billion by the end of year 2030. And by that time, the world population would be around 9 billion by 2050. So there is enormous task to feed this ever-growing population, and we have several challenges facing us and staring at us, like as Professor R.B. Singh Sahab said, temperature, weather hazards, sea level, drought, abiotic and other biotic stresses. And this has been very well predicted by the IPCC 2014, and also by Pathak et al. 2015. And the uncertainty of the vagaries of the weather has been experienced by India on several occasions, and not to forget a couple of days back when we saw in Uttaranchal a glacier outburst. And this is a regular phenomena which is happening more frequently now in the recent times. And when we talk of climate change projections for India, the average surface temperature would increase by 2 to 4 degrees by 2050. And the monsoon rainfall marginally changes. And we have also experienced this year the weather, the winter was preponed, I would say, to 15 to 20 days. And it is also likely to withdraw too early, because in the month of February only, we are experiencing a temperature of around 27, 28 degrees. Number of rainy days, intensity of rains and cyclonic storms are regular things to happen in coming time. And this is all been predicted by the Indian Meteorological Department. So basically, I have categorized the major climate change threat in wheat. Number one is heat, and then it is followed by drought, stress, salinity, waterlogging, lodging, nutrient deficiency, and then variations in pest dynamics. And this has been experienced very recently, because last year we received several of the information, like some of the rice pests like stem borer is shifting to wheat because of the change in the climate, and they are surviving in the fields of rice stubbles. So the increasing temperature usually, as you know, hastens the development, shortens the grain filling period, and severely reduces the grain yield. And temperature increase of 1 degree Celsius during grain filling can shorten the grain filling by 5%, proportionally reduces the harvest index, and ultimately it is reducing the grain yield. The extremes of temperature at sensitive developmental stages are also very critical for the wheat production, and temperature over 30 degrees, as I said, at the time of anthesis. And we are likely to face this situation this year, because we have already experienced 28 degrees, 27 degrees in the month of February, and it may go up to 30 or 30 beyond 30. And also elevated carbon dioxide. So these are major physiological and biochemical effects which heat and drought can inflict on wheat crop, and these are, a serious threat to wheat production and nutritional and food security in the country. So as I said, wheat has role in food and nutritional security, and very well elaborated by Honorable Professor Abhi Singh Sahab. When we talk of 2050, we need to have 140 million tons of wheat production, and by achieving this target, in order to achieve this target, we need to increase by 1.27 million tons per annum. Fortunately, during last 4 to 5 years, we had been gaining at the rate of 3 to 4 million tons, but we need to do researches on genetic enhancements, management of resources, transfer of technology becomes a very important and crucial aspect of increasing wheat production. And in order to achieve all these targets, we need to have a national productivity of 4.6 tons per hectare, whereas we have right now at 3.5 or 6 tons per hectare. Now, when we talk of 140 million tons of wheat production by 2050 or so, it has to come from major wheat growing area, the northern part of the Indo-Gangetic plain, which will and should contribute to 52% of the wheat production. Whereas many a times it has been talked about that the second green revolution is expected to come from the eastern part of the Indo-Gangetic plains. But when we see the contribution in terms of wheat production, it is hardly projected to be around 22%. Surprisingly, the central part of the India, comprising of Madhya Pradesh, Gujarat and other states, are also likely to contribute 22%, and few other states will contribute in terms of 2 to 5%. Since the inception of the Green Revolution, we had seen a lot of landmark wheat varieties, starting from C306 in 1969. And during the past decades, we have seen tremendous improvement and advent of many landmark varieties, and not to name the 2967s, 3086, but they all hovered around 60 to 670 quintals per hectare. But during the last 3 years, we had 3 varieties which crossed 80 quintals per hectare mark, 8 tons per hectare, which has been released for the northern Indo-Gangetic plains and also for eastern part of the Indo-Gangetic plains. The first one is DBW 187, released in 2019 for eastern zone, subsequently released for northwestern plains of India, has shown a genetic potential of 96.6 quintals per hectare. And this is one of the most important candidate for the next mega variety, which is likely to come. And then we talk of DBW 222, which was released in 2020, also has given more than 8 tons. And the most recent one, which the Prime Minister dedicated on the occasion of the World Food Day on 16th of October, DBW 303 has shown a potential of 97 quintals, but an average yield of 81.2 quintals per hectare. So this is one of the remarkable achievements of our group during the last 4 years. And when we talk of growth trajectory of wheat improvement as comparing from 1946-47 to 2019-20, the area has also, of course, increased substantially, but the production has shown a major quantum jump. And this has all begun because of deployment of superior varieties like SD2967, SD3086, and more recently we had DBW 187, DBW 222, and of course HD 3226. So by this way we had been able to achieve, and in this year's final estimates are yet to come, and I am very sure that it will cross 108 million ton for the last year's production. This year also we have started giving projections of the production of current crop year, and to me, as for the data of the area sown and the crop condition, I am projecting 115 million tons of wheat this year. And this will be an enormous achievement on part of the IIWBR and also from the centers of All India Coordinated Research Project. As I mentioned you, sir, that the area since 2000 has changed to 113.4%, whereas production has changed to 778%, and the productivity has also gained from 275%. Since the inception of the All India Coordinated Research Project in 1965. We had been talking a lot about 2967 and 3086. I will not go into details of 2967 because to me the area is declining now. But this is one variety which is replacing very fast the area which is being vacated by 2967. The total estimated area, as for our estimate, is roughly around 5 million hectares. And the estimated production of this variety in the total production is 21.72 million ton, and the value is 418 billion rupees at the rate of the MSP of 2019. And the potential yield, yes, you can see here, is 71 quintals. The analysis of this pedigree shows that parents and grandparents consist of old Indian wheat varieties which are not extensively utilized in the hybridization program of the wheat, and that's how this has become so distinct and different from all other varieties. Now, I would like to devote 2 minutes time on this variety, DBW 187, which has seen an unprecedented seed production by private seed companies. This was released for irrigated timely sown conditions of northeastern plain and was outscaled to northwestern plains and has a potential yield of 97 quintals. The variety has almost all characters which is desired, like chapati quality and all these things. We distributed a mini kit trial in the eastern Uttar Pradesh in Gorakhpur. This particular story was displayed on the ICR website, where a woman farmer, she was illiterate, but Koila Devi, but she could harvest a yield of more than 80 quintals per hectare in the Tarai areas of Gorakhpur and Maharajganj and the other adjoining districts. So far, sir, we had been able to pen down 279 memorandum of agreements with the private seed companies, which is probably one of the highest numbers so far. It is even more than 3086, and we have generated more than 2 crore of rupees through MOA. Now, the response of the seed producers, we have also studied. We took a questionnaire and got their response. And this seed was available throughout the Indo-Gangetic plains, starting from Jammu to West Bengal. Most importantly, sir, you are talking and giving reference of wheat blast. This is one of the first varieties which have been identified at least for high level of wheat blast tolerance and resistance. So that's how it is giving double benefit to the farming community. And you see more than 67% of the farming seed producers were highly satisfied by this varieties performance. And yield levels in different states varied from 6 tons to 8 tons, depending upon the practices they've performed. The varieties which followed subsequently were DBW222, which was released in 2019-20, having a yield potential of 81 quintal. And the last one, the DBW303, which was released only in the month of February this year, has a potential yield of 97.4 quintals per hectare. And this has been recommended for early sown conditions of wherein the fields are vacated early. The October, we have vacant fields and it is lying vacant, and for the want of variety, farmers are not able to sow. So it has got an early heat tolerance also and late heat tolerance also, and this can be sown in the second fortnight of October. And when we see the overall indents of tentative breeder seed indent of wheat varieties for 2021-22 production. This is not, I'm sorry, this is not tentative, this is final now. You will be surprised, sir. I think this is most heartening to see this slide, that out of 10 varieties, which are top 10 varieties of seed production, the 7 varieties are coming from IARI, IIWBR combined. And this is one of the most important achievement. And you very rightly said that this kind of stories can be brought out as a success stories. You see 2967, the indent going down, the Pusa Gautami, the HD 306 is indent is going up, and which is very closely followed by, this is one of the most surprising fact that within 1 year of release, this variety has achieved 3rd position in the breeder seed indent overall. So you can see it is very neck to neck with the top 2 varieties. I am very sure, very confident that this in coming season, this will be #1 variety. And of course, the latest one, the DBW222 is also at the 8th position. And 7 out of this 10 varieties are from IRI, ICR. And surprisingly, we don't find any variety from Punjab Agriculture University. Neither we get any variety except for the Unnat PBW 723. Neither we get any variety from Pantnagar, nor we get from Kanpur, or nor we get from Hisar. All are absolutely finished kind of programs. And you see the rate of varietal replacement, if we consider only the varieties which are released during last 5 years, it has reached to 47.8%. And when we take into consideration the varietal replacement rate for the last 10 years, this is one of the highest figure, and it has never been experienced in any of the crops. 82.8%, which is absolutely magical figure, because wheat farmers are very enthusiastic. They want to replace the seed every year. They are fanatic, I would say, for the newer varieties, and that's how this rate is changing. And when we see the cumulative breeder seed indent of the developed varieties during last 10 years, I think it is 46,000 quintals. And the total share of the last 10 years variety is more than 40%. And when we see this 40%, I think 80% will be from IRI and ICR, IIWBR. So this is one of the important achievements which has happened during the last decade. And this is very unique development, I would say. Of course, not very healthy sign, because all the other centers are disintegrating or not performing well. But of course, IRI and IIWBR could live up to the expectations. Now, seed production, distribution, and promotion has been followed on IRI model. Very honestly, I would say what I have implemented in IIWBR, what I learned in IARI, and I would rather say that in a little bit more refined way, where we identify promising varieties, then potential locations of the and stakeholders are also identified. Then after the release, seed production agreement is done by ICRI, IWBR, and then quality seed production. It takes place for leading to the distribution. And you will not believe, sir, in our campus, you had visited many a times when you were chairman of the QRT. Very limited space is there, but 15 to 20,000 people thronged the campus. I had to call the police in order to maintain the law and order. That was the situation for the demand of these varieties. So I just wanted to bring to your kind notice that as far as varietal replacement, varietal deployment and varietal development is concerned, I think we are highly successful. Now, there has been many comparisons, and then government also has taken data of post-pre for 2014. So I thought, why not? I should also analyze what has happened before I joined this institution, and before that, what has happened. So you will be surprised to see that I took over, and you very well know, in 2016. Before that, only 29 agreements were made for varieties. And after 2016, 492 agreements with the private seed producers were formed. And in terms of revenue generations, only 4.3 lakh rupees were earned before 2016. And after 2016, 259.12 lakh rupees were generated as a resources for, in terms of commercializing these varieties. And revenue generation, you can see from 2011 and 12, it is almost skyrocketed during last 3-4 years. And we are targeting 450 lakh this year. I hope we will be definitely able to achieve this. Sir, during the last year, during Corona time, COVID-19, a very innovative kind of idea was suggested by our colleagues, my colleagues, and we developed a seed page on the IIW website. It crashed on the first day itself because so much pressure was there that almost 30,000 farmers registered on this website. And this success story is also displayed on the ICAR website, the technological intervention for efficient seed distribution during COVID-19 pandemic. And more than 15,000 farmers were given seed by either sending them through post parcel after getting their registration and transferring their money through electronic mode, or they were called in staggered manner in the campus, and this was highly appreciated by the council and elsewhere. Now I will come to the real topic, sir, the managing abiotic and biotic stresses. I will not go into the details, but wheat, as you know, is grown in around 30 million hectares. This year, surprisingly, the area is up 34.5 million hectares. This is also sort of record. The area never has reached this point, 34 million hectares. That's how I'm guessing it will be 115. Wheat suffers losses due to abiotic stresses such as heat, drought, salinity. Minor genes or QTL based tolerance is likely to provide abiotic stress tolerance, and that's how our group led by Dr. KV Prabhu at IARI, and now here I am leading this group. We have initiated incorporation of minor QTLs for drought tolerance and also heat tolerance and salinity tolerance, and we have also initiated work on lodging tolerance, because last couple of years we have seen that there is a huge rain during last couple of years in the month of March, and wheat suffers a loss of the tune of 20 to 30% because of the lodging. And we have employed options like molecular assisted recurrent selection, probably first time in the world in case of wheat, and then MABB and other techniques for incorporating QTLs, which are distributed along the complex wheat genome for deployment in varietal backgrounds. I will not go into the detail, but there is a very famous, and most of our teachers have taught this equation, which was suggested by Pasiora in 1979, where the yield is depending on the photo protection, transpirational efficiency, water uptake, and partitioning of the harvest index, which is, this was further modified by Rainfed and Tuberosa in 2008. And we have followed this for not only incorporating heat tolerance in the most advanced type of facility for screening wheat germplasm in controlled condition, and also for drought tolerance, and high throughput and precision phenotyping is a potential source and option for abiotic stress tolerance screening. And we have also been able to very successfully develop a magic population with the founder line 3086, GW3222, Hi154, and several other varieties which were either landmarked on once upon a time, or they are likely to become. And total of 39,100 single plant harvested F3 generation involving all 8 parents were available, and further advancing is done to develop this population. And we had also been able to successfully fully deploy and accumulate favorable QTLs through molecular state recurrent selection, wherein in certain of the lines from 6 to 8 QTLs have been incorporated, and you can see the change percentage in terms of yield when we compare with that of the checks like HI 1500, which has been a very known source of drought tolerance, and HD 3043 is also our variety, which is also drought tolerant, and DBW 43 is one of the agronomic parents where we have utilized, and we had utilized all the morphological, physiological tricks to map the breeding population to select the desirable plant type, and all these things have been aprogenies of the DBW 43 HI 1500 population has been subjected to high density genotyping with 35K wheat breeder array was used for genotyping, and 2000 co-dominants were polymorphic between HI 1500 and DBW 43. And of these 35,000 essays selected, 15,000 were co-dominant, and the work is now being progressed after bringing the 1100 SNPs were used for mapping. And the genetic linkage map of wheat using this SNP marker in RIL population of the same population, DBW 43, HI 1500 was done. A total of 61 QTLs were detected on 17 chromosomes for physiological and morphological traits in the recombinant inbred lines of the DBW 43 HI 1500 population for moisture stress tolerance. Now, QTL for grain wheat per spike is in fact one of the most important trait. When the plant experiences drought, what is the grain weight in this per spike plays a very vital role in deciding the yield of that particular genotype. And we had been able to, look at the QTLs, which have been on chromosome 3B, 5B, 6A, and 2B. And several of the QTLs listed here have been identified and being incorporated for NDBI yield and biomass, and also for grain wheat per spike. As you can see here, sir, QTLs for biomass under rain-fed condition in DBW 43 1500 population has been mapped, and then we have found them on 3B, 5A, and 2A chromosomes. And this has been based on the phenotypic evaluation over locations distributed across agroclimatic conditions, and the genomic regions linked to drought tolerance based on what we did for SNP genotyping in a different population of C06 and HD2733, one of the most important yesteryear's variety in northeastern plain, and we could find out QTLs for grain weight per spike, harvest index, chlorophyll content, and also one of the important QTLs, one of my student Amasida worked on this, was a QTL for yield under stress conditions. This QTL doesn't expresses in the normal condition, but whenever the plant goes into stress, this QTL expresses, and we get a yield enhancement under stress conditions. And similarly, we had also been following the molecular state backcross breeding program, and the recently published paper of Neha Rai in 2018, it appeared in Plant Breeding, where we had been able to successfully transfer QTLs into HD 2733 background from HI 1500, which has been one of the most important resources for drought tolerance. As I said, sir, this was one of the first publications, which was this research we carried out under the leadership of Dr. K.V. Prabhu, and this paper appeared in PLOS One, one of the first papers appearing for molecular assisted recurrent selection. And this has resulted into generation of great informations, how we can accumulate 6, 7, 8, 10, 11, 13 favorable alleles in single background, and then we can mitigate the drought and heat tolerance beautifully. And similar way, we had been exploiting the genetic variability from synthetic hexaploids also. The synthetic hexaploids, as you know, sir, are very diverse source for resistance to not only biotic stresses, but also abiotic stresses. And then we had developed advanced lines using following crosses involving parents like 2733, 2932, and these all synthetics initially received from CIMIT. 108 lines were received from Mujib Qazi, and now being extensively utilized for incorporating not only biotic stresses, but also abiotic stresses. we had been talking about generating a lot of diversity in our breeding material, and therefore we thought of having a right time to look back to our local land races in order to increase the diversity and adaptability. This paper appeared in Molecular Biology Reports, and this clearly depicts on the basis of principal component analysis that how the land races, the exotic collections, the genetic stocks, the improved genotypes, the mutant lines, and also the varieties are absolutely different from each other, and they can be grouped in different components and utilized for improving the abiotic and biotic stresses. This has been done using comparative marker distribution of 1,46,550 SNP based on physical and genetic map. And there was a correlation of 0.9 due to difference in chromosomal location of SNP based on genetic and physical map. Same way, sir, genomic selection, a modern breeding tool for rapid genetic gain, has been utilized in GBV-based selection for genotyping have been done. And several of the genotypes which has been identified on the basis of their predicted yield, like BRW3877, Raj 4546, DBW306, DBW187. These are the suggested crossing block material for the centers to employ for the predicted high yield and also for tolerance to drought. We had also initiated work. One of our paper has recently appeared in 2019, Kumar et al. In Molecular Biology Report, where CRISPR-based genome editing for wheat has been first time initiated at IIWBR with the help of the coordinating centers of the ECRIP, and we are mainly concentrating CRISPR editing, gene editing for salt tolerance, drought tolerance, heat tolerance, and also nutrient stress. So this is our main concern at the moment, and we'll be progressing in this regard as we get and analyze the data. In one of the recent developments, we have established co-movement between heat and drought stress intensity. And that proves my point, which I had been telling for a long time, that you breed for one drought, one abiotic stress tolerance, there is an automatic improvement of other drought or abiotic stress tolerance. And to name this, one of our variety, which is SG3086, was initially screened for drought tolerance. Now, in the recent study, it has been found to be highly tolerant to salinity and also for other abiotic stresses. And stress intensity indices were developed first time using principal component analysis and prioritize the location for abiotic studies under resource limited conditions. So we are feeling crunch for resources, and that's how this priority has been inflicted, and we can now pinpoint the location where we can get the maximum and good quality results. This paper appeared in Ecological Indicators, which is also very highly rated journal. You have seen, sir, while your visit to IIWBR many times that we have developed a temperature controlled phenotyping facility for precision phenotyping. This has been a great tool in screening material for high temperature tolerance. And mainly focus has been on heat stress and identifying stable molecular markers with greater precision in differentiating high temperature response of genotype in TCF. Many times people say that day temperature has increased. I also been saying this, day temperature has increased, but what play crucial role is the high temperatures during the wheat season in the month of February and March. This has been proved by this study, where a unique field-based movable temperature controlling system was designed to enhance the night temperature. And so special treatments were given in different plots. In the night, the temperature was enhanced. In the daytime, it was kept as normal ambient temperature, and different grades of temperature were there. And then it was clearly proved that high night temperature at grain filling stage significantly affect the physiological and yield traits compared to the vegetative and booting stage under field conditions. So this proves the theory which Simit once said, but people criticize them. But now it is a very valid fact that if the night temperatures are high, then you can rest assured that production is going to get down. If the day temperature is high, nights are cooler, you rest assured there will be not much effect on the total production of wheat in different areas. This has been identification and characterization of multiple abiotic stress tolerance genes through physiological and expression analysis, identified SHINE1 and NHX1 and 2 as multiple stress responsive genes. These genes can act as candidate genes for transgenic and genome editing research, and this we have recently started. We have not come to any conclusive end, but now we are utilizing basically these two genes for incorporating the abiotic stress tolerance. And water has been one of the most important components, and we have installed a modern facility of screening for water deficit conditions, water stress conditions with subsurface irrigation and also the other kinds of irrigation system. And a total of 71 genetically diverse wheat genotypes were screened with high water use efficiency under limited moisture stress, where we can regulate the water stress, and then cumulative pan evaporation for 3 years it was studied. And we have identified 4 genotypes which are highly efficient in utilization of the water. There are two kinds of situation where one is drought tolerance and another is water use efficiency. I'm particularly focusing on water use efficiency. Whatever amount of unit of water you have with the genotype, they should be able to utilize them to the 100% efficiency. And for this, we had been critically undergoing the hybridization program and developing the material for high water use efficiency, because many a times farmers have water but in limited numbers. And as far as wheat is concerned, almost 100% wheat is irrigated. The question is how many irrigations the wheat farmer is able to give. Either he is giving 2 irrigation, 3 irrigation or 5 irrigation, depend upon the water they have. As I said, technology outscaling is one of the important aspect for and one of my topic is the economic upliftment of the wheat farming community. And therefore we have gone for technology outreach by mass adoption. We have also been doing capacity building, food and livelihood security, and yield gain and cost cutting experiments are also there, and they have been very beautifully explained to the farming community. Not to forget about the varieties, but also one of the drills we have developed. There has been a lot of talk about, we have submitted this application for patenting, and I think we very shortly will be getting that. This is all time, every weather, 24/7 drill, whereas in this kind of drill, we cannot operate in early hours or late hours. So that is the advantage. So we are going for outscaling, upscaling of these wheat technologies. And we have also studied wheat varietal spectrum, and you can see these are the older varieties for the last 10 years, but amount of cumulative output in terms of tonnage and the gross value they have contributed in average incremental return to the farmer per year, per hectare, it is enormous in case of wheat. One farmer invests ₹1 in case of wheat farming, what amount of money he is getting back, and that proves your point of deciding the MSP and all those things. ₹1 investment leads to 2.8 rupees gain when they follow farmer practice, and 3.1 in central zone. And here you can see the gap is narrow in northwestern plains. What farmer is practicing and what we are doing, almost to the equal levels, but we need to fill this gap also. But ₹1 investment should earn 4.1, and that means 4 times he should gain out of wheat farming, but he's not gaining 3 in that way. And these are some of the policy advisories for improved livelihood. I will not go into the details. Probably I have overshot the time, some of the important one is the intensive demonstrations of all the technologies we have, propagate the collective farming to make small farms economically viable, and also all the kinds of things, promotion of conservation agriculture, development of genotypes for these things, and technology outreach for role in doubling the farmer income has been undergoing, and we have been able to increase wheat yield across zone states to the tune of 7 to 30%. This is one of the most important aspects, and educate farmer about the benefit of new technologies. Farmer can just by simply employing the new technologies, at least 5,000 rupees the first go he gains. That is one of the important achievements, and if we propagate this over the zones and agroclimatic conditions, I think the conditions of the farming community will improve dramatically. Sir, this is one of the important publications which has come after you did our QRT. And this is policy imperative for wheat procurement. And this has been in great demand now, and we have suggested several of the things. Now you are seeing the agrarian crisis of MSP and mandis and APMCs and segregation of the material at the mandis. These are all burning topics, and several of the under changing realm of economic activities, no, we have been suggesting these, and the present policy document has been supplied to all the state governments. Only a week before, Ministry of Food and Civil Supplies Secretary took a meeting to decide the guidelines for wheat procurement. Should we relax or should we not? And I have given this document. I think this will be a great boon to the wheat procurement and improvement of wheat procurement. Sir, lastly, I would like to tell you very happily that during the last month, January, we have been very successfully been able to identify, catalog, and get the material registered with the Robert McIntosh laboratory and designation of the newer gene, LR80, from India. This success story has been displayed on ICR website, has been published in Theoretical and Applied Genetics paper, has come out, and this has been identified from a local wheat in Himachal Pradesh, Hango 2. And probably this confers resistance to almost all the predominant and virulent pathotypes of Puccinia triticina. And this is only the 6th gene from India, apart from LR10, LR48, LR49, LR57, LR58. And after a long time, I think during last 74 years, total of 223 international rust resistance genes have been catalogued. And India has contributed only up till now, only 5. This is the 6th one. So this is one of the important achievements. I thought I would like to inform the gathering, August gathering. This is only showing susceptible reaction on 16-1, but fortunately this is not coming on bread wheat. This comes on durum wheat, and almost all the races which are there, it has shown resistant reaction. We had also screened the LR37, YR17, SR38 marker, which is known for 2NS translocation, which imparts resistance to wheat blast. So we have started, advanced breeding program without getting the disease in the India. We had been screening through marker, and most of the Indian lines are non-carriers, unfortunately, 74% of them. And fortunately, 26% of these lines have been carrier also, but not all of them have performed equally. There has been a differential response, and we had been screening and identifying varieties. We have also registered in and initiated impact assessment of IIWBR technologies using experimental approach, and we have registered the RCT in global registry at American Economic Association, and established stage village in Karnal, which is likely to expand in other district also. This I would like to skip because most learned chairman has said something about me. I don't deserve more than that. These are some of the awards I have got. Thank you very much for this. And at the end of the talk, I would like to end up with the quote of the Mahatma Gandhi, the father of the nation, that the future depends on what you do today. And I am very confident, sir, during the last four and a half years stint as director of the Indian Institute of Wheat and Barley Research, our research has been such that we can defend any crisis in terms of wheat and barley, and we are always ready for enhanced production through our system and ECRIP. And I am thankful to all the colleagues at IRI, namely Dr. P.K. Singh, Dr. Neelu Jain, Dr. Hari Krishna, and also the colleagues at IIWBR who have contributed immensely, and also not to forget about the students who have worked. Thank you very much, sir.
That's amazing.
Yes, sir. It's your
Thank you,
turn
sir,
now.
Thank you, sir, for your excellent presentation. May I now request the chairperson to give his valuable remarks?
Well, let me say it has been most overwhelming presentation that one can see on a crop which matters so deeply in the system. So what I notice here in brief, if I can summarize, you see, Gannon has been able to bring into the social, economic, ecological, security, and sustainability up front. So this, I think, ecological, particularly when you think of the climate change, the various biotic, abiotic stresses, and so on, the economic gains he was able to show, and the per rupee invested, the returns as they are increasing, the MSP and so on and so forth will be determined by that. And then ultimately the social, who will benefit the wheat farmers. Very often, very small wheat farmers will benefit, and the kind of things that here. So I think it has been a wonderful story of social, economic, ecological security and sustainability. I feel very strongly that the message that has come through our work particularly recognizes that India is worst hit in the whole world by the climate change. A reflection was indicated there, and you can see. And the work on climate change management, CSA, climate smart agriculture, climate smart wheat and rice and many other commodities and crops will be so very important. And therefore, this work is again a step which shows the pace setter. It is the pace setter for future work in the country. Luckily, we have been having during the last 4 or 5 years, even the highest production we achieved in wheat during the COVID-19 pandemic. So obviously there is something beautiful in that golden grain, and that golden grain is ever shining and will continue to shine. And I think this probably has to be maintained and kept going. If 3 to 4 million tons every year being added, even under the worst circumstances, and we have been able to build upon it, then it increases your confidence in the process. And so therefore the agroecologically differentiated approach of development and growth of any crop, commodity, or system is the reply that has come through. And I'm so amazed to see that the wheat yields have been able to cross 9 tons per hectare. And this is amazingly high. I knew this beautiful crop has the potential because of the, you can say, multi-genomic combination in this triple genomes. And this has really been put together, and the yield breakthrough is amazing. And I think if the yield breakthrough is already there, when we manage to make any difference or change, we try to bridge the gap, we try to bridge the bridgeable gap, and then we also elevate the potential yield. And now here we can see a lady farmer somewhere in remote area was able to get 8 tons per hectare or so. It speaks that a differentiated, disaggregated, make the vocal for local, be the vocal for local. And this is exactly what has happened. And this is showing very beautifully in this process. I also note that the parental diversification and the hybridization programs is absolutely as true today as it was ever. Also, the emphasis on public-private sector linkage coordination, particularly in seed production, and the way you have been able to see that the amount of seed gets distributed, the rate of replacement of varieties. The varietal replacement rate has gone so high, and substitution is again a total combination of efforts, which is going through right from whether it is DBW187 or 303, or the emphasis on early sown wheat. As you know, I think your message will be very well received by Bill Gates. In fact, Bill Gates' agronomy has been trying to see how best can we make the early sowing wheat as a distinct possibility with 8 to 9 tons per hectare. If you can obtain under the stress management and avoid the heat tolerance towards the terminal, as well as the sowing periods and the doubly heat tolerant material, if that can be brought into, this is something rare combination. And I think this is again a good relation that we should be able to keep in mind. As I have again, you have proven that IRI's contribution and the contribution of 7 of the top 10 varieties in the country, which are occupying the major area in the country, is again, as I said, I'm sure the director will be kind enough to put together this success story all over in the world, which I think IRI and therefore IRI deserve the commendation of all concerned from anywhere and everywhere, including our own people and government. I would also feel that this should also trigger a message to those leading centers, Pantnagar, Ludhiana, you name it. I mean, these centers should we also be able to take some lessons together, because we have to see that these centers are equally viable and they continue to be there. And of course, we cannot clone Gyanendra and send it to all the places. But those people, they themselves should be able to really reflect what is being done in the system, and which has come in a very disruptive, innovative way. And the disruptive innovations, not only in generation of new technology, disruptive innovation in transfer of technology, the seed portals, the way the seeds were distributed. I think these innovations are as important as technology per se. Innovations are the processes which take the development of research that we have developed for development. So research for development through innovation. And this has been shown very clearly what innovations, technology generation, and research, all three combined together, can make a difference. And this is where I feel the best of molecular biology, the best of the phenotyping. I was listening to the RAC of IRI, the work of Vishwanathan, particularly, if not Vishwanathan, I'm talking about today, very close to each other in the sense they're equally brilliant and bright people. And that work is so much reflected, which RAC, I was able to see that how the basic work of physiological breeding has been really utilized. I think it should be the way forward for all crops. And I think this is a good message, Gyanan, that we have left, and we should be able to see that you are something which is very dear to my heart, reciprocal recurrent selection or recurrent selection, to bring the QTLs together, to build the population, to bring the genetic richness of the population. It is again very unique system that you have followed and you are following through the molecular supported recurrent breeding, which I think is, as you know, North Carolina State University, Robinson, Comstock, and Harvard were the mother and father of these recurrent selection population development. And that makes me very happy, which I have been talking about all the time, including the work on synthetics, the work on land races, the discovery of new genes, particularly LR80. Congratulations for that. And the co-movement that you mentioned about the biotic stresses is really true. Physiologically, very often, physiologically, they meet at the molecular level the way that the genes are able to control one or the other stress at the molecular level. And this is what is proving true. And also, I am so happy that the policy advice that you have indicated, particularly for the pricing and procurement, is again complete, which should be taken due note of. I was just wondering that wheat is a crop, which just my thinking that all which is happening today, that the haplotype breeding, the emphasis on haplotypes, can something be thought of in a more serious way? Because it has paid rich dividends in many cases. And I think wheat is the wonderful crop where the synthetics and haplotypes could become the outstanding way of going about development. Two, I will also feel, because there's so much of seed production, very little work on hybrid rice, hybrid wheat. And I was just thinking with the apomictic F1 possibility now, apomictic seeds F1 production, that some work on this line to further take the potential level of yield could be more than 9 to 10 to 11 tons. That will be a history. And if we combine these new approaches, probably both the dominant gene effect and the additive genes and the QTLs that you are combining together, the hemi or homozygous, all combinations can make a difference. So I will feel that this is a possible new way that you may adopt in your development process and thinking for wheat improvement. Finally, I would like to become more little personal. And the being little more personal is very logical for me. Because when I was at Banaras Hindu University, or even before that, because my home is there and my connection with BHU has been much older than before. Of course, I joined BHU as in 72. And that time, Gyanand was a primary school student, and I will see Gyanand going to school so religiously, so quiet, and he will be still be doing his work, and always a pleasure. I will once in a while come in his way while he's coming back from the school, and so to see the seriousness on the face of this boy. And I felt so happy always, and I will stop by and say, hello Gyanand, kaise ho, kya kar rahe ho, kaisi padhai chal rahi hai. All those things, it takes me back to those days when I was there and he was a primary school student. And I have deeply and closely kept track of his progress all along through his glorious journey from those primary schools to this level as the director of the Indian Research Institute for Wheat and Barley. My heartiest congratulations to you, Gyanand, on this very auspicious occasion, on your winning the prestigious award in the name of Rao Bahadur Dr. Vishwanath. He himself was an outstanding scientist, and you have, by accepting this award, you have honored the science and the scientist, and you are glorifying the what is called the best in science should be glorified at all costs and cases. I wish Gyanand you many more laurels in the years to come. The younger generation, I hope some of the students are also listening to it, must be inspired by your journey and should be able to building better after Corona-19, because pandemic is really shaking the whole world. And I am praying the scientist groups and who are all present here that agriculture will be the backbone of the future development of this nation or the world as a whole. Agriculture, through this kind of research and development, should be able to attract the attention of the policymakers, those who assign funds and so on and so forth to do research, will be bringing, because of health and agriculture. Thanks God, more money has come to health this time. And with more money to agriculture, probably we can build back better India and the whole world together. I think this is the message which I would like to draw. Good science is the driver of the good world. Thank you very much. All the best to each one of you. It is wonderful opportunity, Ashok, for giving me this opportunity to be with you. I always learn a lot whenever you give me the opportunity to be with you and your colleagues. So therefore, thanks a lot. Thank you so much.
Thank you, sir. Thank you so much.
Thank you so much, sir, for your wise words of wisdom and valuable remarks. Now, before we come to the end of the session, I request Dr. Rashmi Agarwal, Dean and Joint Director Education, to present the formal vote of thanks.
Thank you, Dr. Angela, and good evening to all of you. Most respected Padam Bhushan Professor R.B. Singh ji, the chairperson of today's Rao Bahadur B. Vishwanath Award lecture session, eminent researcher Dr. G.P. Singh, and also the winner of 8th Rao Bahadur B. Vishwanath Award, our distinguished guests, Dr. B.D. Singh, Dr. R.M. Singh, and Dr. K.V. Prabhu, our Honorable Director, Dr. A.K. Singh, our other dignitaries, I will name Dr. K.M. Manjaiya, Associate Dean, Project Director Dr. Man Singh, heads of the division, professors of various disciplines of IRI, faculty, staff, students, ladies and gentlemen. It is my pleasure and proud privilege to propose a vote of thanks on this auspicious occasion of this prestigious award lecture session. First of all, I congratulate Dr. G.P. Singh for outstanding achievements and very, very meritorious presentation on this occasion, which has got this prestigious award for him. So accept my congratulations on this occasion, Dr. G.P. Singh. I'm so grateful to Professor R.B. Singh, sir. Sir, you are so kind. You accepted our invitation for chairing this session, and also you summarized the whole lecture of Dr. G.P. Singh and giving lot of inspiration words for young minds, sir. We are so much thankful to you, sir, and you are always a source of inspiration for all of us, not only young minds, even minds like us who are in the nearing end of our career, sir. We are so grateful to our distinguished guests, which I just named, Dr. B.D. Singh, Dr. R.M. Singh, and Dr. K.V. Prabhu, joining this prestigious lecture award session. I'm really very thankful to our Honorable Director, Dr. A.K. Singh, for all his guidance and very meticulous planning and positive attitude for throughout the 59th Convocation Week program. I will fail in my duties if I do not acknowledge the help given by Dr. K.M. Manjaya, who is Associate Dean and very meticulously planning each and every event, including this particular session on the award lecture. Thanks to all distinguished invitees, project director, heads of the division, professors, all the students, and all the other invitees who have joined this lecture series. And I'm sure Dr. G.P. Singh's lecture has really inspired our young minds, because many of the students have also joined, and I see many young scientists. So they should get inspiration that how meticulously and very nicely and one after the other, he has brought out the success stories in wheat crop improvement against abiotic and biotic stresses. So lastly, I would like to thank all the team members, Dr. Burman, Dr. Mishra and his team, Dr. Angela, and those who are working behind the scene to bring a great success to this prestigious award lecture, and also all the other events which we are handling through online mode. So with these words, once again, I thank you, each one of you. If I have failed to name, kindly excuse me, because all have helped in really planning and execution of this our Convocation Week program. So we are ending with this lecture series here. Today's program, sir, this was the 4th